Let's summarize glycolysis in a few minutes. Glycolysis happens in cytoplasm. It is facilitated by enzymes which are loosely associated with the cytoskeleton near the plasma membrane. Here is the overall reaction. You produce 2 ATP and 2 NADH. You also produce 2 molecules of pyruvate, which is further broken down. The first step of glycolysis is going from glucose to glucose 6-phosphate. In this reaction, ATP is converted to ADP, and this reaction is facilitated by an enzyme called hexokinase. Magnesium is a cofactor in this reaction. Here you can see that the phosphate group has been added onto the 6th carbon. The next reaction is going from glucose 6-phosphate to fructose 6-phosphate. This is a reversible reaction and is carried out by phosphoglucose isomerase. Here you can see that a 6-ring structure is changed to a 5-ring structure. The next step is going from fructose 6-phosphate to fructose 1,6-bisphosphate. In this reaction, ATP is converted to ADP and is facilitated through a very important enzyme called phosphofructokinase. Magnesium is a cofactor in this reaction. Here you can see that on this carbon, a phosphate group has been added. The next reaction is going from fructose 1,6-bisphosphate to 2 different products. The first one is dihydroxyacetone phosphate, and the second product is glyceraldehyde 3-phosphate. It is a reversible reaction which is carried out by fructose bisphosphate aldolase. The next step is to convert dihydroxyacetone phosphate to glyceraldehyde 3-phosphate, and this is a reversible reaction which is carried out by triose phosphate isomerase. The next step is going from glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate. In this reaction, NAD+ is converted to NADH with magnesium as a cofactor. The enzyme that facilitates this reaction is called glyceraldehyde phosphate dehydrogenase. Here you can see that a phosphate group has been added on this carbon. The next reaction is going from 1,3-bisphosphoglycerate to 3-phosphoglycerate. In this reaction, ADP is converted to ATP. This is the first time you make ATP. Magnesium is a cofactor in this reaction, which is facilitated by phosphoglycerate kinase. The next step is going from 3-phosphoglycerate to 2-phosphoglycerate. And this reaction is carried out by phosphoglycerate mutase. Here you can see that the phosphate groups move from one carbon to another. The next step is going from 2-phosphoglycerate to phosphoenol pyruvate. This is a dehydration reaction which is carried out by enolase, and magnesium is a cofactor in this reaction. Here you see that a carbon double bond is formed. The last reaction of glycolysis is going from phosphoenol pyruvate to pyruvate. In this reaction, ADP is converted to ATP and is carried out by pyruvate kinase with magnesium as a cofactor. Here you can see that the last phosphate group is removed. Do remember that you have 2 molecules of glyceraldehyde 3-phosphate. Therefore, this process will happen twice per glucose molecule, so you'll get 2 pyruvate molecules at the end of glycolysis. Here is the overall picture. Take a look at the flowchart provided on this page for glycolysis. Here are some alternate names you might have seen for some of the intermediates. You can choose to use them depending on your preference. Fructose is converted to fructose 6-phosphate by adding a phosphate group. ATP is required to drive this reaction and is facilitated with hexokinase. Yes, this is the same enzyme which converted glucose to glucose 6-phosphate in the first step of glycolysis. Entry of galactose. This pathway is also known as Leloir pathway. Galactose is first converted to galactose 1-phosphate using 1 ATP. It is facilitated by galactokinase. Going from galactose 1-phosphate to glucose 1-phosphate is carried out by this pathway where UDP glucose is converted to UDP galactose. UDP galactose is then regenerated through UDP epimerase. Glucose 1-phosphate is converted to glucose 6-phosphate through phosphoglucomutase. This is an important pathway, and you should remember it for the test. Thank you. If you have any questions, please use the comment section below.